Alright, it's 3 o'clock, so let's get started again. So just a reminder again, today we'll end at 4. And so someone asked me about the post that I made about opening files in Python and then reading out from a file. So because I don't cover that in the slides, so I just wanted to do a quick example of that. So how many of you have heard of lorem ipsum? Okay, so if you don't know what lorem ipsum is, it's just basically a bunch of Latin nonsense that people use to fill a page just to see what it would look like before actual content is put in there. So I just have this file with a couple paragraphs of lorem ipsum. So what I want to do is I want to read the lines in the file. So I currently have this file saved in the same directory as the Python file I'm making called example.txt. So the way to open a file in Python, and actually it doesn't apply to just files, but there are other constructs that do this, is with a context manager. So a context manager is basically handling the opening and closing of a particular socket or a stream or file pointer or things like that. So it handles everything for you. So the way to do that is calling with, then the function call, which will do the particular operation that you want. So in Python, that's called open. So what open does is you pass in a particular string, and it will try to open a file with the name of the string you pass in. So the name of the file that I have right here is example.txt. So I'm just going to create a string, example.txt. And then since this returns a pointer to the file, we want to save this as a particular variable so we can do some operation with that. So the way to save it with a context manager is with the as keyword. So as, and then I'm going to call my pointer f. So what f is just basically right now is a pointer to the start of the file. So if I wanted to, let's just say I wanted to read all of the lines of the file all at once, and then have each of the lines be stored in a list. So the first entry in the list is the first line of the file, second entry is the second line of the file, all the way until the end. So the way to do that is to call f.readLines. And then since this returns a list, I want to save this into a variable. So I can call this lines. And so what I can do now is I can do a bunch of things that we've been talking about with lists. So we can look up the length of the number of lines in the file. So let's just do that for an example. So print len of lines. So what this will do is what? Print the number of lines in the file. Yeah, exactly. So let's call Python3 reading file. All right, so there are currently 9 lines in the file. So what if I wanted to loop over each of the lines and print the length of each line? Okay, so so basically I'm going to see 9 lines of output with a particular number, which is the length of each of the lines. So how would I do that? Well, an easy way to do it is loop over the lines, right? So how do I loop over a list?
For S in
Yeah,
line.
yeah. So for S in lines, what do I do now? So what does S represent? Yeah, it's one of the entries in the list. So basically a line in the file. So what do I want to do with S now? Print the length of S. Yeah, because what type is S? A string, right? Because it's reading off a file. It's not going to be an integer or something like that. It's going to be a string. So I can run len on the string and then print it. So if we run this, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly. So what do you think this 1 represents? It's actually another line break. So if we actually look at the file, we can see that. So there's a line break right after this last word, but there's another line break. So that line break consists of one character in the file. Okay? So that's why it says 1 right there, because that's the length of one line. It's just that new line character. Okay? So what if I wanted to read just the first line of the file? Take out the S. But what type is lines now? It's one string. It's not a list. So we can't do this. If I tried to do this for loop as is, what would it try to do?
The length of each substring.
Well, what is S looping over?
String.
It's looping over a string. So what is S representing of the string? Each character. So if I print the length of each character, what's it going to print a whole bunch of times? It's going to print 1 a whole bunch of times. So if we save that and run, which is exactly what we get. We get a whole bunch of 1s. So so just be careful that read line is it's going to read one string out of the file, and then what would f.readLine here do? What would this second read line return? The second line in the file, right? Because this one basically reads the line and advances the pointer to the second line, right? Basically, wherever you see the first new line character, right after that is where this f is now positioned before it reads the next one. Okay? So, any questions on reading files? Yeah.
I get a little confused. So, when you're reading all the lines and it printed out the length of each paragraph, how is it determining that it was a paragraph each time?
It doesn't. So when we did this read lines example, it's reading each of the lines and putting it as an entry in the list. So as just one string. So now I have a list of strings. So what the for loop does is it loops over this list of strings and prints out the length of each entry.
Oh, and each entry is separated by a break.
Well, each entry in the file is separated by, each line is separated by the new line character, right? The f.readLines is basically the same thing as reading the entire file and splitting by the new line character. That's all it's doing. And so lines now is just a list of strings, and it has no idea what a file is now. It's just a list of strings. So when I loop over it, I'm just looping over a list of strings. Okay? So any questions about opening files and all that? So if I tried to access, just as an example, if I tried to access f.readLine here, I think it actually should throw an error, because the way context managers work is with when you do the with statement, it creates the context of where the file is open, like the port is open to the file. And then when you exit the scope of the with statement, then basically you can't access it anymore. It closes the port of the file safely. So if I try to run this, it should give an error. Yeah, the I/O operation was closed on the file. Okay, so it's just knowing what a context manager is when opening file, when to close file. Okay, there is a way to explicitly open a file and then explicitly close the file, but I find this a lot easier to do. A lot more bug-free also.
There's no reason to use the close, right?
No, because
Is there any instance where you would need to use it?
I can't think of one, because this just handles everything for you. Yeah, I imagine there is, but I can't think of one. Any other questions? Yeah.
F is arbitrary.
Oh yeah. It's just a variable name, so I can name this Fred if I wanted to, and then I would just call Fred. Yeah. So the name is just a variable name that you're assigning to the result of open. Yeah. Any other questions? Okay, cool. So we've been talking about, let's see. We've been talking about this thing called the Operator Precedence Table, and we've been making our way through that. So at the top of the precedence table is these 4 operations, subscript, slicing, call, and attribute. exponentiation that is right associative, which works on integers, unary negation plus and 1's complement. Then we covered the 4 multiplication, real division, integer division, so there is an actual integer division operation, and the modulo operator, which is remainder. Addition and subtraction, we know what that is. We covered 2 angle brackets, either left or right, corresponding to shifting left and shifting right on the bits in a particular number. A bitwise and, bitwise XOR, which we probably won't use because we typically don't work with the bits explicitly. Bitwise OR, and then just all the relational comparisons you're used to. But we have a few other ones, such as like in, that we've seen when we try to check if a particular value is in a list or in a set or some kind of sequence. Not in, I hope you can figure that out, that means the value is not in the sequence. So it's basically the opposite of in. Is and is not is basically, how many of you worked with subclassing, or like what is called a child class? So a few of you, yeah. So it's basically doing a check if it's if some object is either exactly the same memory location, or if you can actually do a type on this, and the type is like a subclass of a particular other type. So we don't use those very much, but it's basically a more restrictive version of the double equals or the not equals. Okay. The really cool thing in Python is that we don't need to do some condition and some condition and some condition for relational operators. We can actually just write it like what we would do in math, like A less than B less than or equal to C. So that would actually be equal to A less than B and B less than or equal to C. So there are quite a few substitutions that you can make in if statements where you can actually do a whole bunch of comparisons all at once. And actually, we can actually do quite a few other ones. I don't think this one's in the slides, but I think it's actually important to talk about. So, all right. So one thing that we usually want to check is if, say, we have a list of integers, and we want to check that every single integer, say, is less than a certain value, right? Like if we have a list of integers like 100, 59, 23, negative 105, 96. Okay, so what if I had an application where I wanted to check if every single integer is less than 1,000? Okay, obviously it's true here, but I just want to check if everything in S is less than 1,000. So what would I have to do there? Yeah, so what we would do is loop through the list. So for V and S, so I'm calling the variable that loops through is V. So if V is, well, if I want to test if there is some number at least 1,000, I need to check that. So if V is at least 1,000, then I would print, say, false or something. And then, yeah. And then at the very end, print true. This is actually not quite correct, but the idea is there, right? If we find some number that's at least 1,000, then we print false or we return false or something like that. And in every other case, we print true. But the problem with this is that it can be quite complicated, and there could be some problems in programming this. You could have some subtle errors. So there are actually 2 really good functions in Python called Annie and all. So kind of like how int and stir work, it takes in some argument. So basically, it'll return a true or false value. So if we wanted to do the all function, it'll take a list and it'll return false it'll return true if every single comparison that's made in the all parameter will return true. So it's basically doing a giant AND over everything. But so if we do all, but how do we pass the information that we want to check less than 1,000, right? So if all what? But I kind of want to check every single integer in this list, right? All at once, in one line. But we have, if we wanted to do a for loop over everything, we would have to do that indentation, but we can't do that here, right? So what we need to do is basically what's called writing the loop in line. So what you do is you would write the loop in line, so for v and s, and then if s less than 1,000 for v and s, then print true, else print false. I believe that's how it works. So Python 3 example. No, that's not what I wanted. Yeah, that was actually it. I said let s less than 1,000. Yeah, that was it. Yeah, so you were absolutely right, because when I did s here, s is a list. So I'm basically doing a comparison to an integer, which doesn't make sense. But if I did the integer comparison for v and s, so basically what this does is it returns an iterable, which basically behaves like a list. So what it's doing is it's basically making an iterable for every single element in S. And it's basically returning a value which is the result of this Boolean comparison, which is obviously going to be true or false. So it returns an iterable, and what all does is if every element in the iterable is true, it returns true. Okay? And then consequently, the function any basically returns true if anything in the iterable is true. Okay? So it's almost the opposite of all. So this is actually what's called a generator expression. So what a generator does is it doesn't construct the list. It doesn't construct a list for you all at once. It returns you one element at a time. And then when you ask for another element in this inner for loop, it returns the next element. And when you ask again, it returns the next one. And then when you get to the end, it says, oh, no, I'm done. And then it stops asking, basically. Okay? So just knowing what the any and all function do, all returns true if everything in the iterable that's given to it is true. And any returns true if there's some element in the iterable for which it is true. Okay? So are there any questions about any and all? Okay. Yeah, the number one piece of advice, if you learn anything from this class, is don't give live coding demos. Yeah, because a lot of pain will result. All right. Yeah. So all of these are membership tests on the right-hand side, and the left-hand side with all the relational comparisons are between two operands, whether those be integers or for sequences or something like that. We have the OR, which is basically like the Boolean OR of Java. It actually behaves exactly the same as in Java, but it's little o, little r instead of two vertical bars. Yeah, it's just Boolean OR. And is Boolean AND. So it takes two operands. If both of them are true, then it returns true. Otherwise, it returns false. Okay? It's just like double ampersand that you've seen before. Not is a unary expression. So basically, it takes in one argument, which it will be a Boolean. The result of it will be a Boolean value, so true or false. And what not does, it returns the opposite value. So if it was given true, it'll return false. So, and if it was false, it'll return true. If a conditional else expression, so we have if and else in Python. It's just an if-else conditional that we've seen before. Obviously, some operators behave differently depending on context. So what was one that we talked about yesterday?
Multiplication.
Right, so if we have a string and an integer with multiplication in the middle, that for some other languages that wouldn't work at all. But for Python, what it does, it basically concatenates the string as many times as the number is given, right? So operators behave differently depending on context, like multiplication with strings, but multiplication with integers actually does the multiplication on integers. And like here, I don't know what's going on with the lights.
It must be on a timer.
Yeah, or they hate me or something. Yeah. So what this is basically a string of 9. So it constructs a string, which is just the character 9, times 99. So what would that do? Just the inner part of the int function. 99 nines. Right, 99 consecutive 9. So I didn't want to have to type that. But it's just much easier to just convert to a string, concatenate the strings a whole bunch of times, then convert back to an integer. And then doing a plus on an integer obviously works. Cool. There's actually an easier way to do this exact number. So it actually is 1 by 100 zeros. So does anyone know what that integer is called? Google, right? So what's another way of writing a Google?
Print 1 plus 0 times 99, or 0 times 100.
Well, it's 1 with 100 zeros after it, right?
Yeah.
So
String,
what? Right. So we can do stir of 1 plus stir of 0 times 100. But then what do I do? What would this actually give me?
Just give you a string.
A string, but I want the actual integer, right? So what would I have to do now?
Int and then
Into the entire thing, right? But what's an easier way to do that? It's 10 to the power 100, right? How do we do powers?
double.
A double multiplication, yeah. So 10 double multiplication, so exponentiation of 100, and it'll do the exact same thing, right? So there are some ways where this is necessary, but there are other ways to do the exact same thing. So it actually depends on the integer itself. Okay, so we did that. So assignment, we've seen this many, many times now, but it's just helpful to remind ourselves what assignment is. So it's just a single equal sign. The value on the right is placed in the variable on the left. Is basically the same thing as Java, pretty much every language that you've used before. But we've actually had that example where we had multiple values on the right, separated by a comma, and multiple values on the left, and they assign pairwise in order. So just a single assignment, A equals 3, that's pretty clear. B equals 2, same thing. But we have a double assignment. So the coordinate-wise, they're assigned to the variable on the left-hand side coordinate-wise. So obviously, the number of elements on each side has to be exactly the same. But once you have that, you can assign multiple variables in the same line. So 1 will be assigned to A, 2 will be assigned to B. Okay? Cool. And so if we make a function call called foo, and as we know, functions can return multiple things, not just one thing. So if foo happens to return 3 items, actually 3 or more items, it'll basically be transferred into the first 3 values that foo will return will be assigned to A, the second one will be to C, second one will be to B, third one will be to C. Okay? So any questions about that? Yeah.
Can you assign multiple variables to one
It would give you an error because it's expecting three, from the left-hand side, it's expecting 3 values on the right. But if I had more, it would just assign the first 3. Okay? And what people sometimes do is if they're, let's say that my function returns 5 values, but I only want the middle 3. So obviously I can just ignore the first one. But I don't have an easy way to work with that. So if I, on the right-hand side, I have 1, 2, 3, 4, 5, and I only wanted let's just say those are the values that are returned by my function. So I want to ignore the first value. So what's a really easy way to just ignore a value?
Create a useless variable.
A useless variable. So what people usually do is just do an underscore. And then assign the variables as necessary, and then another underscore for the one that I don't care about. So if we print B, it's 2, C is 3, D is 4. Okay? So what people usually do is using that underscore for things that, for variables that we don't care about. Like in for loops, sometimes we write for underscore in the list or something. Okay? So any questions on that? Okay. So we covered those, but we have the augmented arguments. Like instead of doing a equals a plus 5, what you usually do, like in for loops with Java or some other context, is just doing those 2 operations all at once. So plus equals, minus equals, times equals, all those. Also exponentiation works here, but you can basically put both of those arguments together all at once. Okay? Just as you would expect from some other language. Okay, so sometimes we build a function just to make it so that the function exists, but we haven't implemented it yet. So what you do there, like what do you return from that function, right? Because I haven't made it yet. So what you do is you use this keyword pass. So you define the function and then just write the word pass in the function definition. So what it does is just basically a no-op. It doesn't do anything. So if I made a function, let's just do this as an example. So if I make example 2 pass, so if I make a function foo x, y, z, and I don't define anything there, it's actually gonna give me an error, I believe. So example 2. Yeah, it actually gives me an error because it's expecting something to be indented. Because all functions in Python have to have a non-empty body in terms of like characters that are actually used there, that are not comments. So what you do here is you write pass. So pass is just a no-op just to make something exist there. But if I write that, won't do anything because I actually don't do anything here. But that's good because I don't call the function, it doesn't do anything, I don't do anything else either. Okay, cool. So that's what pass is for.
So just for like something you're going to implement later?
Yeah.
I guess.
Yeah, that's actually what I have as the comment.
Oh.
Yeah, that's fine. So it's just a thing to say that I'm going to implement this later. Yeah. Return, we've seen this many times with a function. It just returns a value. So, but it doesn't just always have to return one value. It returns an expression list, which is basically a bunch of values separated by commas. So I can return multiple values if I wanted to. Break is the same thing as in Java and C++. The keyword is lowercase b REA key, and what that does, it just breaks out of the loop that you're currently in, right? So if I am in a for loop and I just want to get out of the loop once I reach some condition, for example, I just write break, and at that point it'll just exit the for loop. Okay. So any questions about these 3? Yeah.
Is there a continue keyword?
Yes. Yes. Import, we've actually covered this. So it just imports a particular module. So what's a module again?
An object of classes, or a group of classes.
It's almost that. So it's a Python file that has a bunch of methods and a bunch of classes. So it's just a functions and class list. So import the name of the file is just importing the module. And you can actually, as we've done before, we can use the from keyword, module name, import the function name. So we can just import one or multiple things from the file, from the module if we want to. Like import foo, and everything from foo is imported. But from foo import bar, only the function bar is imported. We can chain together imports using commas. So like import module name, comma, other module name. So we can import multiple things on the same line if we want to. All right, so if statements are just, we've seen them many times, but just as review. So they're the same as in Java, C++. The structure is if Boolean condition with a colon, and then everything indented below that is the body of the if statement. So if A is greater than or equal to greater than B, then I'm just going to set C to 1. If A is greater than C, then do some other function. I talked about if and else. Do we have an else if? So what's the name of that in Python? Yeah, elif. So elif is, so elif represents else if. So here it's exactly the same thing as in Java and C++. If this condition right before A is greater than C is false, then it'll fall to this condition, then check A is less than B, and then do that if necessary. And then obviously we have else clauses, which will, if everything below it has said false, then we'll actually do this particular body. Okay? So any question on if and else statements? Okay. So loops, there are actually two kinds of loops in Python. We've been covering for loops, but there are actually while loops also. So it's almost exactly the same thing as if statements, and the semantics of it are exactly the same thing as in other languages. So while some Boolean condition is true, do the body. Okay, it's exactly the same thing as in Java and C++. So let's just say I have this particular body, and then it'll just keep executing this this body until the condition's false. It's exactly the same. But for loops, it's not the same as we've seen. What you do is you iterate over a sequence. So it should really be called for each, because it's for each value in some sequence or some list or something like that. So like for every C in some string, so what will C represent? Well, it's a variable, obviously. But,
in the list.
yeah, so, well, this is in a list, though. It's every character in this string. So for strings, each element that's returned is each character in the string. If we have a list, what would LM be here?
1, 2, 3, 4.
Yeah, so it's every element in the list. Yeah. But we have functions that can return multiple values, right? So what if we had a list which has each entry being like, say, a list? So we have a bunch of lists within one large list. And I want to iterate over each of those lists. And let's just say that each of those sublists has 2 elements, just to make it concrete. So what I want to do is I want to examine the first and second element of each of those sublists. So one thing we can do is we can do for some variable name in this long list. And so what would that variable correspond to for this large list? Every sublist, right? So I can extract out the parameter of each of those sublists, right? Like an index 0 and index 1. We know how to do that. But you can actually do this right in the for loop statement. So you can actually extract elements out of each element that's returned. So you can actually do for A comma B in, I have lists containing tuples. We haven't covered tuples yet, but let's just say that a list containing lists of size 2. So the first element of each of those sublists would be assigned to A, the second would be assigned to B. So it's basically extracting that information out of each of those sublists. Okay? So any questions about for loops and while loops? Okay. Yeah. So we'll cover tuples in a second, but continuing with loops. So what if we wanted to explicitly tell this for loop how many times to run? We know that for loops have to iterate over some sequence, right? But what if we didn't have a sequence and didn't want to make a list saying, oh, if we wanted to repeat this particular body 10 times, I don't want to make the list 1, 2, 3, all the way up to 10, and then just pass that in, right? I don't want to do that. So what's another way? Another way is called range. So what range does is basically it does that list for you in a slightly more efficient way. But it basically returns an iterable from 0 up to the parameter that's passed in. So let's just see this. So yeah, range is actually a very useful function. So example 3 range. So let's just say we have our favorite string, CSE294 is awesome. And I want to print this string 10 times. So I can obviously do print of s, print of s, print of s. Yeah, so that'd be kind of tedious, especially if I wanted to do it more times. But what would be the easy way to do it? I can do print s times 10, right? But what's a way to do it with a for loop? So we have this range function which returns an iterable from 0 to stop -1. So how many elements are in this iterable? From 0 to stop -1. Stop many, right? Because the 0 is the first one, 1 is the second one, all the way up to stop -1, which is the stop one, right? So if we say range of 10, so what this will return is 0, 1, 2, 3, 4, all the way up to 9. Does it include 10? No, because like we've seen before, most ranges in Python and most other languages too are inclusive on the lower end and exclusive on the upper end. So it doesn't go all the way to 10, it goes to up to 10 minus 1, which is 9. So we can actually, for LM in range of 10, all right. So what will LM be here? Yeah, it'll be each of the numbers 0, 1, 2, 3. So, but do I care about that? If I just want to print the string? No, so I can just do print of ln. No, print s, yeah. I remember something else I wanted to say. But example 3, and it prints it 10 times. Actually, the example we did earlier where we wanted to do print s times 10, what would the difference be between this and doing it this way? Yeah, because every time we want print, it adds a new line. But here, it's doing a whole bunch of concatenations, then a new line. So it's not adding those 9 new lines in the middle, right? There's actually a one-liner way to do it, but this is actually a lot easier to just say the range that we want, and then a useless variable, lm, I don't care about that, and then just do the function that we want to do it some number of times. Okay, so that's what the range function is. So it basically just returns, in one sense, a list containing the numbers 0, 1, 2 up to the parameter -1. Obviously, the argument must be an integer, right? Because if you pass in something else, then that would be a problem. What if I wanted to? What if I had some other string like? Teaching is fun, but I wanted to loop. I wanted to print CSE294 is awesome, the number of characters in t. So it's not like range of 10 anymore. It's the length of t that I want to print s now. So how would I change this? Len of t. But where am I going to put that len of t? In place of 10, yeah. So len of t. So if we run that, it'll print len t of this string to the console. Okay, so any questions about that? Okay. So there's actually a variant of this. So instead of just passing one parameter, let's just say I wanted the actual numbers, 0 up to some number. But I don't want to start at 0. Maybe I want to start at 10 or something. Well, you can provide a two arguments to range where it's exactly the same semantics, but you start at the first argument. So if I pass 10, 20, and that's it, so it'll return an iterable from 10, 11, 12, up to 19, instead of 0 to the whatever parameter we passed. But there's actually an optional third argument, which is, like we've seen when we did the slicing example, is the step. So instead of going up each integer once, you can go every other integer. You can go backwards if you want to. All kinds of things you can do. Okay? So yeah. So it'll return start plus 1 up to stop minus 1 if the step is not given, and instead of plus 1 here, it'll be plus step if the step number is given. Okay? Cool. Range 10, as we've seen, is an iterable containing 0 up to 9. For I in range 10, we can print I. For n in range, so here the start is 0, the stop is 101, and my step is 2. So I should print out 0, 2, 4, 6, 8, all the way up to 100, right? I actually have a bug in the slides, so that should say 0 up to 100. But yeah, so we can have that step integer if we want to, but we don't have to. So here we have our start being 10, our stop being minus 1, and our step being minus 2. So it should print. So it should give me 10, 8, 6, 4, 2, 0, and that's it. So that's what it's returning me. Because if we go below, then we went below the stop. Okay. So any questions on range? Okay. Function definition can return expression lists, so we can return more than one value if we wanted to. The arguments of a function are obviously called function arguments, but that's just the actual name given to it. Identifiers in the function header are the parameters. Variables created in the function have local scope, so the variables that you create within a function can't be accessed outside the function. But you can actually, let's just do this example for functions, the py. So you can have a function which takes let's just say it prints, but let's just say I have a global variable t is 100 or something. But if I wanted to access t inside this function, so let's just say print t or something, and then we tried to do func of testing. So what should this do? What do you think will happen? So it'll print testing, then it'll print 100, right? But sometimes we will actually, there are some contexts where you can't access that global variable, or sometimes you have another variable that's created in scope with the same name, but you want the global version instead. So what you do there is you do a global t. So what that means is whatever t is made before me, I want the one that's created globally before me. So whatever the last assignment to t was right before me, that's the one I want. Okay? So that's just an introduction to global. But sometimes, like here, since it's unambiguous, yeah, it's unambiguous, then we know we want that particular t. But sometimes you do need that global there. All right, cool. So functions are also types. So you can pass functions around just like you can do with variables. So this is just a simple example. A square which takes an integer returns the multiplication of that integer with itself. Cool. So there's no main function in Python. In a sense, there's no like main that you can call function. So obviously, simple hello world applications print a particular string, but the problem with importing modules is that when you import a module, it'll execute the module, which is kind of weird, right? So what if we wanted to import a module, but we didn't want to execute it at all? What would we do? It doesn't seem really clear how to determine when we're called from the Python 3 interpreter versus being imported from another file. So what you do is you use what is called a system-created global variable. And so they're usually called dunder, which means double under. So any word that has two underscores on both sides of the word usually means something important in Python. It's something Python exclusive. So whenever we call Python or Python 3 on a particular file, the name of the module that's returned to us is under main under. So to determine if we're being called by the Python 3 interpreter, we call if dunder name, so double under name, is equal to the string double under main. So if this is true, then we're called from the Python 3 interpreter. If not, then we're being imported from somewhere else. Okay? So we can create our own main function, which will only execute when we're called from the Python 3 interpreter. And if not, since everything else now is in a function, either in main or some other function, then nothing will be executed, right? So that's exactly what we want. So add this line of code if you want to import from another module, but you don't want that module to execute, but you want to execute that module sometimes just like for testing purposes, okay? So yeah, so some built-in functions. Just familiarize yourself with a few of these. We've seen a few of these, like integer, len, list, some of those. But there are some other ones like ABS, which means absolute values. So you can pass in an integer and it'll return the absolute value of it. But there are some ones that are actually really, really cool, like the all and any that I've covered earlier today. But there are some other ones where you can pass in a generator expression, such as like max and min. So max and min behave like any and all for what it takes in, but it returns the actual maximum of the list or the generator that you give it. Min gives the minimum one. Reversed returns the iterable reversed. Sorted returns like a sorted version of the list or the generator you give it. Sum gives you the sum. So there are actually quite a few built-in functions which are really simple, really short, and actually express a lot of power for things that you've done before. And a lot of these come up a lot, especially in math applications, so it's easy to just write sum of a particular list and it just returns a sum. So, and it's actually quite efficient in how it's implemented. Okay, cool. So, how much time do I have? All right, cool. So named arguments, as what I've mentioned yesterday, is probably my favorite Python feature. So how many of you have used a function before which has a bunch of arguments in it, but you didn't know what the argument order was? So like you didn't know if name, like the name of a person was the first argument or the second one or something like that. Like the order wasn't very clear to you, and then you had to go look it up, and then it's just a pain to deal with, right? Yeah, everyone's had that problem. So named arguments actually solve this problem. Yeah, remembering argument order is a pain. So what you do is in the function, like in the actual implementation of the function, in the argument list, you write as an optional argument the name of a variable equals some default value, right? And so if you just call the function normally without any named arguments, it'll be assigned that default value, right? But if you wanted to assign directly to it, you would actually, when you call it, actually say the name of that optional variable equals the value that you want. So just as an example, this is my function which takes in one argument mandatory, but it can take in 2 more if necessary. So param1 is obviously required, param2 has the default value of 10, param3 has the default value of 1. But I could change those if I wanted to. So let's just say it has some definition. So function can take in 1 argument, no problem, but it can take in 3 arguments. So foo is obviously assigned to param1, so what do you think 30 is assigned to? Param2, and 23 is assigned to param3. So you can call this function just as you did before. There's no backwards compatibility issues. You can just call it exactly the same thing as before. But you can actually set a particular argument. So as I said before, param2 and param3 are both optional. I don't have to include them. But if I include them, then I can actually set param3 equal to 100. So when I actually call func. So what that does is it replaces the value on the right-hand side of the equal sign of when I'm calling the function to where param3 is declared, which is in the argument list of the actual function. But the actually really cool thing is, this location, it doesn't have to be after foo. It could be anywhere. As long as it's actually declared somewhere, it could be anywhere. So let's just do this as an example. So example 5, named. So let's just say we have this def func, param1, param2 is 10, param3 is 1. Let's just say it prints print param1. And so actually I'll do all 3, param2, param3. So I'm not sure if we covered this, but what do you think the print statement does with commas in between?
Spaces out.
It spaces out, yeah. So I can obviously call this with func of foo, func of foo 3023, func of foo param3 is equal to 100, but I don't have to have param3 in that location. I can have it anywhere in the function as long in the argument list as long as I assign it to the same value. So param3 is 100 foo. And obviously I must have 1 argument for param1. That's a required argument, but if I wanted to assign an optional argument, I can put that anywhere I want. So if I run this, example 5. Oh, actually, no. Maybe not. Yeah. Don't listen to me. Yeah. I guess the order actually does matter here. So as long as it's after the required arguments, the order doesn't matter. So I can actually have param3 is 50. So here I have the order reversed. So if I run this, it'll actually still work. So I assign in this last one, param2 is 20, but 20 is printed second because param2 was printed second. So as long as it's after the set of required arguments, the order of the optional arguments does not matter. Okay? So now if you add named arguments to your function, you don't have to worry about the order, right? You can just assign the particular named arguments that you want and nothing else. You don't have to worry about what order they are in. Okay? Any questions about that? Yeah.
Could you get around that by saying like param1 equals 2?
I think you can. Let's see. And then I think you can. Good question. Yeah. So it actually. So what do you think? Since param 2 is assigned 10, obviously. What do you think param 1 is default assigned to? None. Yeah. Good. So yeah. So if we explicitly make it a named argument, then we can obviously permute the named arguments in any order we want. But that would require knowing what the unnamed argument was. So you would have to know the implementation of it. But if you know the named arguments, you can put those in any order after the required ones. Yeah. Cool. Any other questions? All right, cool. So we'll do one more slide, then we'll get out of here. So we've talked about inputting from the user. So that's just calling the input function with no arguments if we don't want any output. But if we want a prompt or something, then we fill in that optional argument with a string. So prompt is a string written to stood out, so printed to the console with a trailing new line. Input reads in a line of text, converts to a string, and returns that. But we also have named arguments here. So print for outputting. For print, objects is just the comma separated list. So it's either one or more elements. But we also have this separator thing. So if we have a bunch of objects we want to print, and we set separator equal to like a space or something, it'll automatically make a space between them. Or maybe we can set the separator to a comma or a new line or something. We can also set the end, the very last character. Instead of being a new line after each print statement, we can just make it the empty string. So the next time we print, it'll be on the same line. Okay? So that's the way to get around when we had all those prints being on separate lines. You can just set end to be the empty string or some other string, depending on what you want to do. You can actually set the file of where you're printing to. So if you open a file, you can actually pass the file pointer and set it to file, and it'll print to the file instead of standard out, which I think is pretty cool. And flushing the output after this print, it means like it doesn't stay on screen. It'll just flush what you've printed so far. Okay. These are called named arguments, obviously. So we can call print 1, 2, 3. So end is the string ABC. So and separator is the space. So what will be printed? A 1 followed by a space, which is the separator. 2, separator, which is the space. 3, and then at the very end, ABC. And then when we call flush, once we're done, once we print something else, it'll flush what we've printed so far. Okay? And as I said, the named arguments can be in any order. And someone asked yesterday about C-style formatting, like %f. I'm not sure if %f exists, but what you can do, actually, yes, it does. So you can do a modulo operator. So that's actually another example of an operator being used in different contexts. So just like in C, where you have like %d, the arguments will be after the % sign after the string. But the way that this is done is through a tuple, if you want more than one, if you want to format more than one thing. And we'll get to tuples, I think, next time. So any questions before we break? Okay, cool.